Hey guys, so this week our professor asked us to create a 5 to 10 minute long video talking about the different rocks that we learned about these past few weeks. And we're going to be discussing the different textures, compositions, properties, and how these rocks were made. So I decided to go a little different. Instead of using the rocks found in our kits, I actually brought out a few rocks that I found here in Tucson in some of the local hiking trails. And actually, one of the minerals, rocks, fuel, comes from a store that you can find any day, every day. And so to start off, we're going to go with igneous rocks. Igneous rocks is one of the first rocks that we learned about, and it essentially involves rocks being thrown out of a volcano, and the way that they cooled determines their characteristics, determines their textures, and their composition. So the main compositions that you look at involves color. You have felsic rocks, which are usually lighter in color, and the mafic rocks, which are darker and deeper in color. So to demonstrate that, I brought out pumice as a felsic rock. Now the interesting thing about pumice is that it is a very light rock. It has a lot of holes in it. It's very porous, or it's very frothy, if you want to use texture terms that we learned. And this is because when it was cooling, it cooled so fast that all the air that was coming out, all the water that was evaporating from the heat, created pockets that hardened and created a low dense rock. And this one most likely cooled very fast on the Earth's surface, which is why it cooled fast. But then you have a mafic rock like coprolite, which I believe cooled inside the Earth's crust. It was insulated, meaning that it was exposed to more minerals that melted together. And most of the time, mafic rocks are larger because since they cooled slower, they were able to eat up, collect, bring in as many minerals as they could, creating a denser, larger rock. Now, coprolite is darker in color, suggesting more minerals inside of it. And there's a few blemishes on the surface. There's cracks, crevices, things like that. And if we're talking texture, I say it's aphanetic, because although there's cracks and things like that, the areas that are flat don't have many blemishes. They're pretty flat, they're pretty straight with not many minerals mixed in. So the next type of rock that we're going to talk about are sedimentary rocks. Now, sedimentary rocks are so the next rock that we're going to talk about are sedimentary rocks. Now, sedimentary rocks are what they sound like. They're sediments of another rock that congregated, collected, and it became a different kind of rock. So you can find that as chemical sedimentary rocks, which for this case I actually brought out some rock salt, which is a precipitant from a solution, ocean water essentially, that gathered into crystals and created a crystal. You can see through them. They're hard, they're brittle, actually pretty salty. And that's a good way to identify a chemical sedimentary rock. Something that's brittle and harder in general, especially compared to clastic sedimentary rocks, which are normally considered muddy, softer, and they leave a residue either in your hand or on a harder surface. In this case, we have blue calcite, calcium, something that's built up. And in classic rocks, it's interesting, more of a longer story, where a rock has been weathered, eroded, and it's been transported by water, by rivers, by wind, and deposited, and through lithification, it becomes a different kind of rock. And you get this from chalk. That is another thing that you can find in a riverbed. Clay, things like that. And the interesting thing about sedimentary rocks is that they can also leave clues to history. So oftentimes when you go into a riverbed, you see dried cracks in the surface that can become fossilized, which are fossilized mud. And it tells you, or you can come to the assumption that there was water here that dried up probably a long time ago, maybe not too long, but it left this sedimentary imprints. Now, the last type of rock that we're going to look at are metamorphic rocks. I found metamorphic rocks to be much more interesting than igneous and sedimentary rocks because it gives us more of a peek into our past, into the earth. These rocks are not found on the surface like igneous and sedimentary rocks. These rocks are actually found in the crust, deep in the earth, and it's like a time capsule for the earth. These rocks occurred because earth-moving events, earth-changing events, applied heat and pressure to these rocks, eroded them off the earth, and remade them again to create layers in mountains, to create layers in the side of the Grand Canyon. Up and down, it affects the entire earth. Now, metamorphic rocks are broken up into foliated and non-foliated. Foliated essentially is layers of different rocks that can be aligned or can be banded, which are squiggly. Now, in this case, I brought out two big rocks. This is actually some slate that you can find in Sabino. Now, it is layers, and it actually has two different kinds of rocks here. Now, this tells a story of, different heat, different pressure that was applied. Just like in baking, you can have the same ingredients, but apply different heat to them, and it's going to be something different. You could apply a different time that it's in the oven, and it's going to have a different texture. It's going to be a different pastry in and of itself. Now here you can see a more mafic side, which is darker, probably had more minerals, and it solidified in a different way compared to this lighter side, which is more mafic. Now it's pretty dang brittle. I actually just broke some now, and you can see the layers that it has, And then another example of this, which is a larger piece, and it's more, you can see the different lines in it, is this rock right here that I actually found in my backyard. My dad likes rocks. And you can see the actual layers of the darker rocks and the lighter rocks. Lighter layers, minerals, things like that. And I actually just took a trip to Mexico where I saw, rocks, or I saw a valley that had metamorphic rocks sideways, as the video suggested, that were vertically aligned. And I found that super interesting, oh, there's a pug right there. But that is essentially what we learned in a quick summary about the different rocks, about the earth we live on, and about the history of, how life was made, how earth, breathed and evolved just the way that humans breathe and evolve over a longer period of time. I'm excited to see what the next module has in store for us. And, my eyes were really opened up to, what we have outside our very own door. We're not going to be taking this thing for granted for a long time. I can tell you that. So thank you for your time, and, can't wait for the next class.